Flyby Probe. A flyby probe is the simplest form of deep space probe. It travels past a planet, moon, or other object without stopping, collecting data during its brief encounter. This type of mission is often the fastest way to study distant worlds because it avoids the fuel needed for orbiting or landing. One of the most famous examples is Voyager 2, which flew past Jupiter, Saturn, Uranus, and Neptune, giving humanity its first close look at many outer planets. Flyby probes are important because they can cover huge distances and visit multiple targets in one mission. Their short encounters may seem limited, but they often reveal discoveries that guide future missions. In deep space exploration, flybys are often the first step into the unknown.
Orbiter probe. An orbiter probe is designed to enter orbit around a planet, moon, or asteroid and stay there for long-term study. Unlike flyby probes, orbiters can watch changes over time, map surfaces, and monitor weather or atmospheres. They provide a much deeper understanding of a target because they stay close for months or years. Missions like Juno have helped scientists study Jupiter's storms, magnetic fields, and deep internal structure. Orbiter probes are powerful because they act like prudent observers, sending back detailed information day after day. They matter because deep space is full of systems that change over time, and only orbiters can truly watch those changes happen.
Lander probe. A lander probe is built to touch down on the surface of another world and study it directly. These probes carry tools like cameras, drills, and sensors to measure conditions on the ground. Landing in deep space is extremely difficult because every world has different gravity, terrain, and atmosphere. Huygens is one of the most famous examples, landing on Saturn's moon Titan and sending back images from its strange frozen surface. Lander probes matter because they allow direct contact with another world. They turn distant objects into real places that can be touched, measured, and understood up close.
Rover Probe. A rover probe is a moving explorer on the surface of another world. Unlike landers, rovers can travel, inspect different areas, and study a wider region. This mobility makes them especially useful for planets and moons with complex landscapes. Curiosity rover is one of the best-known rover probes, exploring Mars and studying whether it once supported life. Rovers are like traveling laboratories, carrying scientific tools while making decisions about where to go next. Their movement gives scientists a bigger picture of a world's history. In deep space missions, rovers are valuable because one location is rarely enough to understand an entire planet.
Atmospheric probe. An atmospheric probe is built to enter and study the atmosphere of a planet. Instead of landing or orbiting, it moves through layers of gas, measuring pressure, temperature, winds, and chemical makeup. These probes are especially useful for giant planets where there may be no solid surface to land on. Galileo probe entered Jupiter's atmosphere and sent back direct measurements before being destroyed by pressure and heat. Atmospheric probes matter because they reveal what lies beneath cloud layers that orbiters cannot fully see. They help explain how planets form, evolve, and behave deep inside.
Sample return probe. A sample return probe collects material from another world and brings it back to Earth. This is one of the most complex mission types because it combines landing, collection, launch, and return. The value of these missions is enormous because scientists can study real material in laboratories. OSIRIS-REx brought back pieces of an asteroid, helping researchers understand the early solar system. Sample return probes matter because physical samples often reveal details that remote instruments miss. They connect deep space directly to Earth, bringing pieces of distant worlds into human hands.
Comet probe. A comet probe is built specifically to study comets, which are frozen time capsules from the early solar system.
These probes may fly past, orbit, or even land on a comet. One of the most historic missions was Rosetta, which orbited and studied Comet 67P and deployed a lander onto its surface. Comet probes matter because comets preserve ancient material from the birth of planets. By studying them, scientists learn how the solar system began and how water and organic materials may have reached Earth. They offer a rare look into the distant past. Interstellar Probe. An interstellar probe is designed to travel beyond the edge of our solar system, into the space between stars. These probes are built for extremely long missions, often lasting decades. The most famous examples are Voyager 1 and Voyager 2, both of which crossed into interstellar space after exploring the outer planets. Interstellar probes matter because they study the boundary between our solar system and the wider galaxy. They help scientists understand cosmic radiation, solar winds, and the environment beyond the sun's influence. They are humanity's farthest travelers. They offer a rare look into the distant past. Solar Probe. A solar probe is a deep space mission focused on the sun itself. Instead of traveling outward, it moves inward, closer to the sun than any spacecraft before. These missions study solar winds, heat, and magnetic fields. Parker Solar Probe is the closest human-made object to the sun, flying through its outer atmosphere to gather data. Solar probes matter because the sun controls space weather, which affects Earth, satellites, and communication systems. By understanding the sun better, scientists can better protect technology and human activity in space. Deep Space Observatory Probe. A deep space observatory probe acts like a telescope far from Earth, placed in space to study distant stars, galaxies, and the universe itself. Unlike planetary probes, its target is not one world, but the cosmos. James Webb Space Telescope is one of the strongest examples, observing ancient galaxies and distant planets. These probes matter because they help answer the biggest questions about the universe, from how stars are born to how galaxies formed. They extend human vision far beyond Earth and make the deepest parts of space visible for the first time.